going over, thank you. Today we'll be going over Introduction to Fiji, and we'll be looking at basic operations. Before we go, who we are a group of scientists and physicists at Emory. We are led by Dr. Adam Marcus, who is our scientific director, Laura, who is our technical director, April, and I. We are the imaging scientists, and Stoyan is the physicist, as well as the main person who you need to reach out to for data. And Neil is our ex-co-director. I'm grateful to him that this course initiated while he was here. So I'm going to thank him every single lecture. Okay. At ICI, we help you with consultations, be it your experimentation. Before you bring your samples over here, we help you image with samples. We train you. We support with anything just to do with microscopy as well as image analysis. And this course is part of the education series, which is also something we do at ICI. As always, consultations are free. At any stage in your microscopy process, do reach out to us. We will help you. And of course, it's free, just to reemphasize. We have 19 different microscopes around the campus: Whitehead, Winship, HSRB, and Clinic B. These are all spread over. When you come to us, we guide you to use the most appropriate microscope for your study, for your purpose. So it's not like, you go to April, you go to Laura, or you come to me. We just want you to keep over here. We will help you use the most appropriate microscope that suits your need, okay? And what happens at the end of microscopy is you get enough data, and helping analyze data is the motto of this workshop that we are gonna go through over coming weeks. You can stay in touch with us and come to learn everything that we do at ICI from our website, ici.emory.edu, as well as stay connected and chatty at Emory ICI Slack. Okay. So today's agenda, we will be doing some housekeeping stuff. We'll go over Introduction to Image Analysis. That is something carry forward from last time. There are some people who are new, and I do want them to understand what images are. So I'm gonna revisit some of the stuff that I talked for a few minutes today again, and then dive right into using Fiji and the exercises that we have planned for you. Just part of housekeeping, you can chat on Slack channel. There will be some exercises that I would like you to show the answers. So, copy, paste, take snaps of what you have in terms of the exercises and post on the Slack channel. I did mention last time that I will be posting things on GitHub, but I just realized before posting that GitHub does not accept TIFF or any of the microscopy files. So I have switched onto Google Drive, where you can download the material and you can fill up the survey form. Okay, so if you are joining us for the first time and you have not filled the survey form, please do, because this will be the primary mode of me reaching out to you over email every week, the way I've been doing with other people. And if you haven't downloaded any of the course material yet, please do so. We will be posting the link on Slack, not on Slack, along with Slack, which is already posted, but also on Zoom chat. So you have that with you. All right. So I'll give you a minute to get adjusted with what you need to do. And at this point, I really want to ask you all, does everybody have Fiji installed? And did anybody have an issue installing Fiji or so? Okay, so if you have any issues, do let us know. We'll help you out with that. So if everybody is all good, kind of a thumbs up or something will really help us to know that it's all perfect or fine, or just send a message that it's all good, something like that.
As Gaurav said, if you can see the screen, there's a reactions button. If you can give a thumbs up once you're done, we can see that in the participants list, and that could be helpful, knowing when everyone's ready. So
I also want to go to the next slide and mention that in the housekeeping, in the emails I sent you earlier, I did post a link for installation of Fiji for PC and installing Fiji for Mac. They are the same animals once you are done, but there are subtle differences when it comes to installation. So I've posted that too. I believe everybody has access to it. The video goes over installation of Fiji, updating Fiji, and installing plugins using the update side on Fiji, as well as increasing the memory using RAM. Okay, so I believe everybody is okay since I don't hear, or we don't hear, any issues yet, which is really good. Okay, so Yasmin has an issue that it's read-only. Yasmin, if what you can do is you can drag Fiji wherever you have installed. Let's say if it's in download folder, put that back onto some other place, but it should be in your applications folder. Okay, so if you put your Fiji into applications folder, that should work out for you. And I believe you are using a Mac most likely. So let me know if there is an issue. And feel free to unmute yourself and let us know. It's okay for anybody to unmute yourself and ask us a question. Wonderful, great. So I'm going to wait for 1 more minute for everybody to settle down and have the folders that they need for next of the exercises. And you can find a PDF to the presentation I have right now in the Google Drive folder that you will be downloading. So you can have access to all the slides in advance. And this will be my goal for every week, to have slides in advance so that you can follow along in case you think that I'm going a bit faster. Okay, so I will get going. I believe everybody is okay. All right, so just to recap from last time, what is an image, right? So when you look at an image, it looks perfectly fine, perfectly okay. But if we zoom into an image, it's a bunch of pixels, right? So images are composition of different pixels based on the camera that you are acquiring, or based on the photomultiplier tube, which is translating the image, translating the signal into an image eventually on a confocal, and that's what you end up seeing. And if we look at pixels, they are nothing else but a bunch of numbers, right? And the question then is, where are these numbers really coming from? So these numbers are really coming from the bit depth of the images, right? So typically on a microscope, we are acquiring either a 8-bit image, a 12-bit image, or a 16-bit image. And depending on the bit depth, you will have what I like to call certain shades of grays. So if you have, let's say, an 8-bit image, the way you can know what is the dynamic range of the image, you can use this equation, which is 2 to the power of n, and n is for the number of bits. So 2 to the power of 8 equals to 256. So you have a dynamic range of 0 to 256. And the lowest one, 1 to 256, the lowest one, 1, is going to be black in color, and the brightest 256 is going to be white in color. Everything in between will be different shades of grays, and each of the shade of gray will have a number assigned to it, right? So that's going to be from 2 all the way to 255. Similarly, for a 12-bit image, it's going to be from 0 to 4096. And you will have everything in between, which are shades of grays. And with 16-bit image, it will be from 0 to 65,000 or 65,500 to be more precise. All right. So that's exactly where these numbers are coming from. And we will be looking more about this in details and playing with all of this today. Okay. So a bit of an anatomy of Fiji as to what you have. So what you have in terms of Fiji is a bar, right? Once you start Fiji, you will see a bar over here. You have a menu bar, you have a bunch of tools, and the status. The status over here tells you a lot of different parameters of your image. You also have a search bar. Now, what you are seeing over here is specific for PC. This is how it's going to look in PC. Okay. And one important thing, there are a bunch of icons in the toolbar that you are seeing. Wherever you see this little triangle, little red triangle, if you click on that, if you right click on that, you should be able to see a bunch of options and toggle between different options in the toolbar. If you double click using the left click twice, it should give you various options, and that option could either be increasing the width of the line that you are using and so on, or the thickness of the line and so on, right? So once we start doing exercises, I recommend you play with some of these tabs on the toolbar so that you kind of get an idea of what these things are, okay? And I'll walk you over the search bar. Sometimes, and most of the times rather, I don't like to go in, click, 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 and then go to something because that's 3 or 4 clicks. And if you keep on using Fiji more frequently, you are in front of your computer, what's going to happen is your fingers will start to hurt after a while. So what I like to do is I like to type in the name of my plugin or something that I'm searching for, and then it really pops in front of me. Okay, and we will go over all of this. And this is something that it looks on Mac. Now, one thing I like really about Mac is everything is the same. Literally everything is the same. The only thing that is a bit different in Mac is you can do search in 2 different ways. One is the way I told you right here at the bottom right corner. But if you look at the top right corner where it says help, if you click over there and you type in something, let's say I'm typing brightness contrast. I want to look at brightness contrast. And if I start typing brightness contrast, it brings me right over where the brightness contrast plugin or menu is hidden, right? So it really shows me the path to it, which is go through image, adjust brightness contrast. And that way you end up learning a lot more. And I wish something like this existed for PC, but it is what it is, all right? So going back to anatomy of Fiji, particularly what we will be doing today is we will be exploring some of the options which are part of edit, which are part of image, and which are part of analyze. And in particularly for analyze, we'll be looking at setting the scale, the histogram, and the plot profile. We'll be using histogram and plot profile quite a bit today, okay? And everything else that you are seeing, all the way from measure to set measurements, we will be using quite a lot of this next week, all right? So moving on, because I use Fiji quite a lot, these are the shortcuts which are extremely helpful, and this will be very helpful for some of the things that we'll be doing today. So if you want to take a picture of this, keep it on the side, or you want to go back into the PDF that you have downloaded and keep on accessing that, feel free. What I'll be doing is every time I am doing something, I have a habit of not going into the menu and pulling things, but I directly use the shortcuts. So I will be speaking these shortcuts while I'm doing this. So you also kind of get into the habit of remembering them. All right. So some very simple shortcuts, zooming in and zooming out. So you can use the plus and minus keys on your keyboard to zoom in and zoom out. What happens typically with images is you keep on opening a lot of windows, and it's kind of annoying to go and hit X button on every single image. So to close any of the windows that are part of Fiji, you can hit the key W, and that will close the window that you have. Some of the things which are, again, part of the exercise, which is to look at the histogram, the plot profile, and the ROI manager. So the shortcuts for them are H, K, and T. And again, I don't expect you to remember all of this right away. I will keep on speaking all this keys to you as and when I'm doing something. We won't be doing any thresholding today. That's going to be next time. But Shift Control T is for threshold. We will be doing some of the orthogonal views today. But the two other shortcuts that will come very handy today are Shift Control and C for the brightness contrast window, as well as Shift Control and Z for the channels tool. Okay, so I'll be going over all of this. All right. So what I'll do, the goal of the exercises is I have divided each of the things into small chunks so that if you have never used Fiji, it's very palatable to you. You can easily use this. And I'll show this to you for about 5 to 7 minutes, give you my thoughts, and then let you do it by yourself. Okay, so this is going to be much more interactive. And while you are trying to do something yourself, if you think that you are lost, you don't know what you're doing, please unmute yourself or type yourself up in the chat and feel free to ask us questions. We are here to help you. The point of this course is for you to learn along as we move forward and not just for us to show you things and, say bye to each other. Okay. All right. So exercise 1.1, as it says over here, open the nucleus gray image. And again, I should really tell you what is the goal of this exercise, right? So the goal of this exercise is to familiarize yourself with some of the menus that I told you about Fiji, and go ahead and adjust brightness contrast, and realize that when you are adjusting brightness contrast within the image, what you are doing is you are changing the on-screen display of the image and nothing else, i.e. you are not changing the pixel intensity value of the image. It's helping you see the image in a better way. Okay, so what I'll do is I'll go ahead and open the image which I have given to you. Go ahead and into my Fiji. What I'll do once the Fiji pops up is go and drag the image into Fiji. All right, so once I drag the image into Fiji, it's going to, so typically it asks, do you want to start the updater now? I don't want to at the moment, so also remind me later. And now it should open. All right, so the image opened over here, and it's telling you right now what version of Fiji I'm using and so on and so forth, what version of Java that I'm using, which is right over here, right? It was over here, you know what I'm talking about. Once we go into the image, things become much more dynamic, right? So if I'm putting my cursor onto the rectangle, it shows that I'm on rectangle. If I'm putting my cursor on oval, it says I'm on oval. Something I was mentioning about, I'm right-clicking now. So I right-click, and it gave me a bunch of different options: rounded rectangle, rotated rectangle, and so on. If I double-click with the first, with the left double-click, it shows me a bunch of options, which is what color do you want, right? What stroke width do you want? So let's say by default, it's giving me a yellow rectangle. And if I have a different preference for the color, I can double click and say, okay, I want to use a pink color. And then it's gonna be pink in color, right? So it's completely your choice what you want to do. And you can also change the stroke width and so on, okay? So let's keep it at there and go back to what we want to do. So we went over all the tools and the options in the drop-down menu. The three different things that we will be using today is the edit menu, the image menu, and the analyze menu, okay? So when I showed you earlier, I just took a snapshot of a small area, but there is much more that is part of it. Okay? And next week, we will also be using quite a bit of plugins. Something I if you watched the tutorial of installing Fiji, you must have seen how the StarDist plugin was installed. And later, we will be going into the Fiji update site and installing some of the plugins to do something else. Okay, so something very easy breezy. Let's go and zoom in and zoom out into the image, right? So one of the nice thing with Fiji is if I put my cursor on this nuclei and then I go zooming in and zooming out, so I'm pressing my plus key, it zooms in to that nuclei, okay? If I keep my cursor right over here and I keep on zooming in, I'm just pressing my plus key, it will go to that area, all right? And to zoom out, I'm using the minus key on the keyboard. Next is the brightness contrast menu. So a few different ways to bring that up. You can type in brightness and it will tell you, okay, this is what you're looking for, right? And it tells you if you want to go and access that in the path, you can go to image, adjust brightness contrast. So I can go to image, adjust brightness contrast. And when you go and do it this way, the advantage of or the benefit of doing it this way is that you will end up reading about some of the other options available to you, right? Which is, okay, I can do some color balance, I can do some thresholding, I can adjust the size of my image, and so on. So you will get much more familiar with what Fiji has to offer to you. Or you can use a shortcut, which is Shift Control C, all right? So I'm gonna go and hit run over here, and that's gonna bring up brightness contrast window for me. Let me close that, and now I'm gonna just hit the keys, which is Shift, Control, and C. That also brings up the brightness and contrast menu. Now, what's happening if I change my brightness and contrast, right? So a few other things in the image. If you look right over here in the image, and let me turn on the annotation tool, okay? So it tells you a few different things. One is something in microns, and it's in fact telling me the size of the image in microns because I have calibrated the scale from the microscope I use, right? So that's why it's giving me information in microns. It's also telling me the aspect ratio, which is how many pixels it has in X and Y directions, which is I've got 262 pixels in X and 248 pixels in Y direction. It's a 16-bit image, and the total size of the image is 127K, okay? So what does it mean it's a 16-bit image, right? So when I told you earlier, if it's a 16-bit image, the expectation is that the dynamic range is going to be from 0 to 65,500. And precisely that's all that you are seeing right over here, right? Which is in the brightness contrast window, it stretches from 2874 to 32320. Now, if I click on set at the bottom, it shows me that the bit range right now is set to automatic. But if I want to see everything getting displayed from 0 to 65,500, I can go and click on the 16-bit. And then if I say, okay, now the entire scale of 16-bit image is getting displayed. I'm from 0 to 65,500, okay? And in terms of adjusting brightness contrast, sometimes what will happen is you are not using the entire scale, okay? So let's go ahead and bring up the histogram. So if I press H, and instead of just telling you shortcuts, I'm gonna type in over here histogram, and it tells me the histogram is in analyze and histogram, right? So I'm gonna go to analyze and go to histogram, and that's Control H. I bring up the histogram, and if I click log scale, now you know that my minimum pixel intensity is 798 and my maximum is about 33,000, right? And everything after 33,000, there is nothing over here. So when I am adjusting my brightness and contrast, so again, when you try to adjust brightness contrast, depending on which window is open, it's going to adjust brightness contrast for that window. So if I go back and click on my image window and try to adjust brightness contrast, right? Again, we are seeing that 16-bit dynamic range. So I can change this, right? And the image looks brighter, okay? So the image is looking brighter, and if I click live over here on my histogram, what you will see is the image is looking brighter, but the actual pixel values are not shifting anywhere. The only thing that is changing is the region right here. And if I annotate this, I want you to focus on this region over here, right? What's happening in this region is the region where it says everything is supposed to be white after 32,699, because my max is right now 29,000. So wherever I'm gonna take the slider bar of my maxima, so this is the minima, this is the maxima, I'm sliding my slider bar towards the left, towards the minima. And if I say that it's about 45,000, everything which is 45,000 and higher will have a value of white, right? So that's what you are saying. If I play with 0, it's the same thing, right? I'm reducing the values of black. So everything which is, let's say, 28,000 and higher, so everything from 0 to 28 will be completely black. So kind of the display will think it's just 0, okay? So this is what's happening when you are adjusting with your brightness and contrast, all right? So what I want you all to do is go ahead and play with this small thing. And then in 5 minutes, we can go and jump into exercise 1.1, all right? So I'll let you all play with this. And feel free to unmute yourself and ask any questions if you have any, all right?
I have a quick question.
Mhm.
The max that I have for my pixel count is 32669, not the 655 number. And my histogram looks more like the histogram that's on like the bright and contrast panel as opposed to
Right.
the as opposed to the one that you have. Is there a reason why I'm showing so many fewer pixels?
So what I did was I had changed my display
Oh,
from
I must have missed
automatic to
this.
16-bit. That's okay.
Okay.
So if I go back to automatic, what Fiji does, it scales the display to fit the actual intensity of pixels. What I wanted to show to you later on was that the image that you are using is in fact a 16-bit image. And if you
Mhm.
look at the full scale, the dynamic range of the image, which is in fact from 0 to 65,000,
Mhm.
it looks something like this versus, I'm actually, hold on, my brightness, okay, looks like this. But if I go back to my automatic one, it looks like this. Sometimes what happens is you do want to see the raw data the way it is and not
Mhm.
automatically scale. And that's why I was showing this to you.
Okay, okay, cool. Okay, cool.
Make sense?
Yes, thank you so much.
Yeah, you're welcome. how is everybody doing? Is it okay for us to move on?
I have a question.
Yes.
So the file that I have in TIFF format that shows me the pixel size of 262 by 248.
Right.
But on the histogram, it's a little bit different, like 300 into 240. So why is it so?
300 into, okay, so that is the dimensions of the histogram window itself. That's not the dimensions of your nucleus gray file. Okay, so
Okay.
these are two different windows, and this window has a dimension of 300 by 240. It's an RGB image and so on. So all the all the parameters you are seeing over here is specific for the histogram window.
Okay, that makes sense. Thank you.
You're welcome. All right, so I guess we'll move on to the next part of the exercise. And so if we go to 1.2, we will still be dealing with the same image, which is nucleus dash gray. And the goal of this exercise is to help you learn some new features, which is how to crop image. And rather than cropping the image using the cropping function, I like to use image duplication function, all right? So I'll demonstrate both of them to you, and you can kind of realize why duplicating an image is better. Second thing, most of the things you do these days, we are not limited to the size of our hard drives, right? The data storage is not an issue. So never make any changes to your raw data. Always duplicate an image and then play as much as you want to. And that's where duplicate command really comes very handy. And we will be playing with brightness contrast window with this image. And what I'll try to do is I'll try and set anything that I'm changing with my brightness and contrast, okay? And we will try to see what happens when you change it that way. All right, so let's start with the first part. The first part is I will be duplicating my current image. So I'll go on the image and then I will right click, all right? And once I right click, it gives me a bunch of options, right? And I'm gonna click on duplicate and it tells me what name do I want and so on. So I'm fine with whatever name it gives to me. I'm gonna say okay, and I get the same image as the duplicate of that. Now, I'm going to go back to the histogram, right? Because I want to demonstrate the danger of you changing the brightness contrast and then clicking on the set apply button. Sometimes you're like, oh, well, let me just go ahead and click random things because the image looks very nice. I want to keep it that way. The goal of the course is to analyze data, not just to have pretty pictures, right? So just in case if you end up clicking on set, apply, saving things the way they are, and then use that image for analysis, what are the pitfalls and danger? That's what we'll be looking at now, all right? So I go over here. This is my original image. This is the image that I duplicated. I click on the new image that I have, and then I go to brightness and contrast, right? So now I'm playing with this image, with the duplicate. When I say this, the duplicated image, all right? So now I go ahead and increase or decrease the minima. The other thing you can also do is play with brightness contrast, which means you are scaling it left and right completely for the set range that you have. And same thing with contrast, you are scaling it in a different way, right? So play with all of them and see how you want to scale things. And let's say if I scale something like this, all right? And then I go ahead and set and say, that looks fine to me, say okay, and I go ahead and apply to it. When I apply to it, keep an eye on how this is going to change. Your histogram is going to change, okay? So I click on apply, and what you see is it assigned new pixel values to the entire range, right? So now it's assigning a 16-bit depth to the image where I set the histogram. So now if I go and bring up my histogram, so I'm gonna press H for histogram for this image and press H for histogram for my original image, right? So I'm pressing histograms for both my images, and I go ahead and click on log scale for both of them. And what you will see is, actually, let me bring the brightness contrast for this to 16-bit and say okay. All right. So if you look at the entire range from 0 to 65,500 for the original image, as well as for the modified image, what you will see is the pixel intensity is all over the place from 0 to 65,500. Whereas for the original image, it's between 0 to 32,000, right? And this is the danger that you should realize when you are clicking on buttons such as setting and applying. You cannot use this image to analyze your data. This is only good for visualization purposes and nothing more than that. Okay, so that's one thing. The other thing I want you to do is, let's say, draw a line using a plot profile tool. All right, so I'm going to use this line over here. And we will be using something called a plot profile. So let's say I draw a line and I want to know the distribution of my pixel intensities, okay? The distribution of the pixel intensity all the way from here till here. So I'll go ahead and press K, which is for plot profile, but you should know where it comes from. So I'm going to type in plot. It's behaving. I'll just go away. I know it's from analyze and plot profile. So I'm going to go ahead and click here, right? So it gives me a plot profile right here. So what it's telling you, it's telling me is that it starts from 0. Let me zoom into the window. Okay. So it's telling me that the intensity of the pixels right in this area is about 1500. And the highest that you are getting, and let me just do this. This does get a bit tricky. Bear with me for a second. Okay, so if you keep an eye, right, let's say if I try to draw it somewhere in this area, right, the number which is changing as I keep on moving with my Y, you can see that it's telling you what is the pixel intensity at that particular area. And because we are going from dark into bright and then again into dark, we are getting a bell-shaped curve or a Gaussian kind of a curve, okay? Now, the second thing I want you all to learn is how to use the same line onto the other image. This will be very important as you keep on doing analysis on different images, because you want to maintain a constant region of interest, right? So this line is on a particular region of interest. And now if I move this line, nothing is changing on my plot profile. But if I click on live, it changes the plot profile and it's becoming dynamic, right? So it's dynamic in terms of the y-axis, and the x-axis is pretty much constant because the length of the line is the same. All right. So what if I want to use the same area and want to analyze the same area on the other image? What you can do is you can store the region of interest, and you can store the region of interest by clicking on the tool T for Tango. Okay, so if I click T, it brings up something called ROI Manager. And this ROI Manager now has a particular location for this particular line. So now if I I'm doing something and boom, it got lost. I'm like, oh, I don't know what region I was analyzing. I can click on this on the ROI manager and boom, I'm back over here. Okay. So I'm going to go on to my second image. So I'll click on my masked up image, if I may. And if I click on the ROI manager, I again get the same line at the same region. Okay. So now that we have the same region that we are trying to plot a profile for, I will also bring up the plot profile for the masked up image by clicking on K, K for kite. Okay, so, or K for kappa. And what you see is if we compare the plot profile or distribution of pixels between each of them, it's really evident how masked up this is, because the dynamic range is from 0 to 65,500. If you see a flat curve like this, it means this is all saturation. Okay, so we are going from, let's say, a nice bell-shaped curve to a very terrible looking bell-shaped curve, and that's because everything is very saturated. Okay, so the functionality of region of interest is very, very helpful, the ROI manager. We will be using this a lot in future. Okay, and you can have multiple regions of interest. Let's say you cannot just, if you want to, instead of using a line, if you want to use, let's say, a rectangle tool here, we can also use some kind of a rectangle tool to investigate the same thing. And I can hit T as in tango and bring the same one for the second one and do a plot profile for this area, which is in rectangle. Okay, so if you are analyzing movement of different things and so on, this can be very helpful. A plot profile or line profile tool can be very helpful. All right, so that's that. So we went over the ROI manager. We compared the histograms and the output that came from the original image and the masked up image. And the last thing I want to go and demonstrate to you is you can duplicate a small area, right? So let's say if I want to duplicate this small area, I'm duplicating this and boom, I just get that small nucleus that I want to play with. So I'm going to zoom into the nucleus, right? And it looks very much pixelated. It's bound to be pixelated because I'm zooming into a very small area. And now I want to demonstrate to you that images that we are playing with and dealing with are just a bunch of numbers. Okay, so we'll go ahead and let me clear all my drawings. We'll go ahead and go to the menu of image, transform, and click on image to results. Okay, when I do that, I can see a bunch of numbers. I can see numbers which are zeros, numbers which are 65,500, which means all of this is completely saturated. Okay, and you can create an image from these numbers. All right, so if I go back to image, I go to transform and I go to results to image, it generates an image for me. Okay, so images are nothing else but bunch of numbers. And then as you appreciate that they are nothing else but bunch of numbers, you can do a lot of mathematical operations, which is exactly what we'll be doing next week. All right, so one more thing. This is a 16-bit image, and hence you are seeing numbers which go from 0 to 65,000. So let's kind of, come on, try to, it's really trying to be a pain to me. All I want to do is, okay, I'm just gonna scroll this way and get it out of my way. But if you want to, let's say on this image, you want to change the bit depth. How do you change the bit depth? So you can do that by going to image, type. It shows it's a 16-bit image right now, right? So it'll be coming back to this menu again in future because we need to do some RGB color kind of stuff. So you can go and click on 8-bit. And when I click on 8-bit, you will see this is 8-bit right over here. And in this situation, if I go back to image, added, image, transform, image to results, everything is from 0 to 255 instead of 0 to 65,500, right? So that's how we ended up changing the bit depth of the image. And sometimes you might do it for different purposes. And if I look at the histogram of this image now, and I bring up the brightness contrast table, 0 to 255. And if I go back to my histogram, let me close this. My histogram is from 0 to 255, right? And again, it's really terrible looking in log scale because it's all over the place, all right? So these are some of the functions and menus that you will be using quite frequently as we proceed into next week. And that's why I wanted to show all of this to you. And one last thing, of course, you know, you all always say that, oh, I want to have a nice color on my image. So we can always go and assign a lookup table to your image. You can make it red, you can make it magenta, you can make it different colors, you can make, you know, high-low, and so on, right? So with high-low, something that we always tell you is what is saturated, what is not. So anything which is this super red is completely saturated. And this is what you end up seeing when you are taking your data while you are on the microscope, okay? So that's where I'm gonna pause and give you about 7 to 10 minutes to play with different things. And again, if you have any questions, just unmute yourself and let us know.
I have a question. So when I zoom into a small region to get that one nucleus and I do the image transform image to results, I don't get 0 values. I still get numbers all over the black spaces too.
Okay, so probably you used, so the zeros depend on how you have changed your image. So let's say, for example, if I duplicate my image right over here, and right. I know in my histogram, if I bring my histogram up, that it starts from 1190, well, sorry, it's from 1056 to 32,000 and so on, right? So if I was to do image transform, image to results, I'll be seeing things which is up to 1500, which is exactly what this is, because my minimum is about 1000. So everything in my background is about 1000, and that's what you are seeing. So to answer your question, if you want to see these numbers which represent your image, what you can do is really mass up your image, right? So I can open my brightness contrast window, Shift, Control, and C. And even better, I can make this an 8-bit image instead of a 16-bit image. So I'm going to go and make this an 8-bit image, which is what I just did. I will scale this down and set and apply that. So now everything is from 0 to 255 or somewhere over here. And now if I was to, again, do, let's say, image transform, image to results, now everything is 0, right? So all the numbers that you are seeing really is based on the pixel position that you have. So if your pixel intensity of this pixel, let's say, is about 1200 or 1000, that's exactly what you will be seeing over here.
Got it. Makes sense.
Yeah.
Thank you.
You're welcome. I will give you a couple of more minutes. I hope everybody's doing okay. Let us know if there are any questions, all right? I'm going to move on with exercise 2.1. I hope everybody is comfortable so far with what you are doing. So this was just a very simple single image that you were playing with. Typically on the microscopes that you acquire data from, the images are not just single channel the way I showed to you earlier, right? They are multi-channel images, and though the image I've given to you, which it says drag and drop the just right.oib image onto Fiji toolbar, OIB is a very particular file for FlowView 1000 microscope. This could be ND2, this could be LIF, this could be Zeiss's CZI file, right? So you can have any sort of an image file that comes from the microscope that you can drag and drop onto Fiji. And if it's a file which is other than TIFF, what's going to happen is it's going to open something called Bioformats Importer. Okay, that's how this window looks like. And by default, this window will only have something like this, which is hyperstack. And what hyperstack means is if an image has got multiple channels, it's going to put all of them together in one single stack, and that's what a hyperstack means. Within the stack, you have an option of how you want to open the stack. Okay, so the stack order and so on. By default, it's here using X, Y. So first is X and Y dimension. Second bar that you have an option to change is channels. Then is the Z, which is the depth, and then is the time. So typically, if you have a time-lapse data set with multiple Zs and multiple channels, the organization would be channels first, then the Zs, and then the Ts. And I'll talk about that once I open the data. All right. You can also organize your data sets if you have multiple files. You can group files with similar names. You can open up files individually. Let's say if you're opening files from a folder with individual TIFF files from a time lapse, and you click on files, open files individually, you will have hundreds of images spread throughout your desktop. Okay. So these are pretty much straightforward. And one good thing about bioformats is if you don't know what each of the options are doing, as you hover on a particular option in the information window right here, you get the information of what each of these do. All right. Sometimes you do want to change, you do want to split the stacks. So let's say if I want to split my channels or split my Zs or split my time points, so you can enable all these options to split your channels and so on. Okay. The only option that I'm going to enable right now is display metadata. All right. And that's important because you need to know how the image was acquired. Second is memory management. In the video I posted about installing Fiji, I talked about increasing your memory, which is dependent on the RAM, because the images that Fiji reads is based off of RAM. Now, when you use virtual stack, what's happening is it reads the image onto your hard drive. But if you are adjusting brightness contrast for an image which is read using virtual stack, let's say if you have a time lapse and you go and adjust brightness contrast for one single frame, if the image based on virtual stack, it will only change the brightness contrast for that one frame and not all the frames. So if you load your image using RAM or the memory option, if you uncheck virtual stack and then you load, then it will affect the change on literally every single stack or the image you have within the time lapse. Okay, so these are a bunch of words. We can play with these options and try to understand what's going on. So let's just, what I'll do is for the moment, check on the display metadata and say, okay. And it's giving me an error because there is something wrong with my Fiji, and probably you should not be seeing this. And if you ever get an error, just ignore that. All right, so first thing that you are seeing is the pixel bit depth. It's a 12-bit image. All right, so it's a 12-bit image, but here it's getting displayed as a 16-bit image. And that's the reason why everything is looking very dark. All right, and then it tells me the dimension order, which is X. The size, the XY or the aspect ratio is 512 pixels by 512 pixels. And then it has got all the parameters of how the acquisition was done, right? So it tells me about the PMT gain, the offset, and so on and so forth, the number of channels that I have, what kind of objective I had used to acquire my data. So this kind of a metadata is very helpful to convince somebody that this is what your original image is. You haven't messed up acquiring your data. All right, so that's where metadata comes very helpful. Now you can uncheck metadata when you open the image, because every time you open an image, you don't want to deal with this window. So I'm going to go and hit W. That's going to close the window. All right. So let's go back to this image where everything is looking dark. Now I'm scrolling between my images. You can use the scroll bar on your mouse, and that will help you scroll between different channels. Okay. You can also use the arrow keys on your keyboard, and using the arrow keys, you can also toggle between the channels. All right. Now everything is dark. So I'm going to go back to my brightness contrast window, Shift Control C, brightness contrast, and I'm going to go to set, and I will go ahead and say automatic. Okay. So if I do automatic and click on reset, it gets displayed between whatever the best display is, whatever the pixel range is. Okay. So sometimes clicking on reset is also very helpful. And if I go and back to set or automatic, I can also go and say I want 12-bit range, because that's exactly my range is. It's a 12-bit range. Okay. So now you can see the differences in my image, and each of the channels, whatever the image is. I have a nuclei, I have actin, and I've got mitochondria over here. Okay, and I can adjust the lookup table the way I want to. All right, so I'm gonna keep this blue, as people like to see. And one thing you will appreciate is blue is a terrible color to use. Somehow people have gotten into their head that nuclei should always be blue. But again, it's really terrible to see nuclei when it's in blue. You have to really try hard to see it. Okay. So I typically like to keep my nuclei gray. I'm going to change my channel and make this green. And for the love of God, don't use red lookup table. There are a lot of people who are colorblind and they cannot see red very well. Please use something like magenta, or a color which is easier on the eyes of people who are colorblind. Okay. So, and if you want to see what happens to somebody who is colorblind, you can go to image. Stan, do you remember what that was for the people who are colorblind? I think it was color and, okay, here on. So if you can go down to color and simulate color blindness, right? So it asked me to change this to 8-bit RGB. So this is kind of a right place to show you changing something to RGB. So let me make this red, okay? Change this to image type RGB color. Boom, I got this 3 images. And if I go back to image, color, simulate color blindness, it's asking me, I'll just say normal, okay? And I go over there, image, color, blindness, let's say somebody cannot see red. So if somebody has a proton PIA, the red color appears to them like it's yellow. Okay, so I mean, this is how they will see all the colors. Green will appear like this, magenta will appear like this. So try to be a bit neutral and friendly to them. All right. So I'm gonna pause for 5 minutes over here, let you play with images, understand a bit of metadata, try to look at how the image window looks like, change using different options. You can use the scroll bar, use the arrow key to move between images. It tells you there are 3 different channels. And if I go from one channel to the other, it tells you I'm on the first channel of the third channel, second channel of the third channel, and the third channel of the third channel, right? So this is how you can change between channels and you can know what's going on. So enough of me talking. I'll let you play with this for about 3 to 5 minutes, and we'll reconvene back at about 5:20-ish.
I do have a question. I'm trying to go for the colorblind palette, I guess,
Okay.
and it's giving me a sort of an error that says, let me do it again. That it requires an 8-bit image.
Right. So what you can do is when you are on this image, you can go to image type and convert that either to RGB color or 8-bit. Okay, so right now we are on a 12-bit image kind of, but you can convert that to 8-bit or RGB color. And then you go to your color and color blindness, you should be able to get it right.
Okay, let me try. time RGB. There you go. There you go. Thank you.
Yeah, you're welcome. All right, how is everybody doing? Thank you. Okay, I'm gonna move on to the next exercise. Okay, so when you are dealing with a multi-channel image like this, right? And again, the brightness contrast, the display is not that great. So I'm gonna enhance the display of my image and make it look a bit more nicer. Okay. And once it looks nicer, I want to look at all three channels together. All right. So how do I do that? In order to look at all three channels together, I can open something called the channels tool. Okay. And that is, if you type in here, channels, right? So it shows you a lot of different options that begins with channels. So I can go to channels tool. It tells me it's an image color channels tool with image, color, and channels tool, right? And the shortcut is Shift Control Z. So once we are in channels tool, it shows you that you have got three channels, 1, 2, and 3. And if I make this composite, I can see all three channels together. Okay. And now I can toggle between each of these channels that I want to see. And then if you zoom in, all right, so I can zoom in. Now again, my image looks really, really terrible because I wanted to save some space. I did not zoom in physically when I was taking the image, and it's a 512 by 512 image and not a 1024 by 1024. So, you know, it looks enough from a distance, but when you zoom in, it looks really terrible. So don't judge me, please. It's only to make images a bit smaller. All right. So now, when we are in composite mode, if I again want to change the brightness contrast of one of the channels, right? So I'm gonna go back and press Shift Control C, which will bring up the brightness contrast menu. And if I change the brightness contrast here, okay, so I'm in channel number 1. So if you look at this, I'm on this as an, I should annotate. It's pretty bad of me to say, look at this. If I annotate this particular area, so I'm on first channel right now, and when I'm changing my brightness contrast or my maxima, I'm only playing with the first channel. If I go to the second channel, you can see that this is becoming green, right? And now I'm in my second channel right here. And when I'm changing my minima and maxima, I'm only doing stuff with my green channel. And the same thing, I can play with my third channel, right? So it's pretty neat that you can adjust different channels on the fly like this, even in the composite mode, which was not, it's funny because when I change something, it resets back to original. So Fiji has changed few things in recent. So the best way to change dynamic range is to go to individual colors. And then if you adjust that and you do composite, it's still not changing. All right, Fiji has changed something recently, and this is exactly why things don't look familiar to me the way they used to be. But what's supposed to happen is you change this and you move to the next channel. You change that, you move to the next channel, and all of this should be able to stay the way it is. What might really help is if you change this to 8-bit. Let me reopen. I just want to make sure I'm not playing with the image where I converted something to the color blindness scale. Okay, it is what it is. The best way to play with this is if I change this to an RGB color image, and then if I change something, it will stay the way it is because that's what RGB is meant for, right? And then if I increase this, boom, right? Everything stays. This was just the 16-bit image issue. Yeah, that's all I can tell you. With RGB, once you are here, I can do a composite, say okay. And switch between channels, okay? And that's what you get. So that's creating a composite image, which you can, let's say, copy and paste. And the other way of also adjusting color balance is using this other option. And only if I can find my Fiji back. Is going back to your Fiji and looking for image, adjust, and you play with color balance. You can toggle between channels right over here. Right, and this is exactly the problem I'm talking about, that the display is changing as I move between channels, which should not be happening. So yeah, that's what it is. If I was to save this as TIFF, right? So right now it's in OIB format. I can save my image file, save as TIFF. And then if I try to open that image, just right, TIFF. Let's see if that's gonna be a little bit easy on me. So I'm again going to open the channels tool, which is by Shift, Control, and Z. If I do color, open my brightness contrast window, Shift, Control, and C. No, it's still doing the same thing. And this is new for me. I don't know if it's my OIB image file or something else, but yeah, this is new for me because I also downloaded Fiji brand new so that we are all on the same page. So I'm not sure if it's the new version of Fiji which is doing this, but ideally it should not be happening. Okay, that's all I want to tell you. But you kind of got the gist of where we are going with this in terms of looking at composite image and adjusting the contrast of a single channel. Let me try one last thing while we are troubleshooting. If I convert all of this to 8-bit, let's see if 8-bit is any more better than. All right, so if you convert your image to an 8-bit image, then it's able to retain the color changes that you have made or the display changes that you have made, okay? So the easiest thing I can tell you is if your goal is to display this image and show this onto a PowerPoint, all you can do is convert your image to 8-bit, right? So go to image, type 8-bit, and then it should be able to retain the changes that you have made. Okay, so boom, 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 right? So I'll open my channels tool, Shift Control Z, compose it, and it's able to retain all those changes. Okay, so convert to 8-bit, it should be able to retain. And then I don't know if I talk about saving something on PowerPoint. I don't. Let me just okay, I do in the next slide, so I'm gonna save it for the next slide. Okay, all right, so I'll let you play with that. Go to 8-bit and then play with this color settings, and that should help you. So we'll give you like about 4 to 5 minutes to play with that. All right, so I want to kind of disturb you with what you are doing. Just figure out what was going on. What was going on was when, let me just clear my drawings. When it is set at a particular bit depth, so let's say if I'm setting it up for 12-bit, which is what my image is, and then if I change any display and go to the next channel, it does not retain the same display. So if you want to retain the changes that you have made in the display, don't keep it to the actual signed range or unsigned range over here. Just keep it to automatic. And when you keep this to automatic, it will keep the way you have changed in the brightness contrast, and that also works for a 12-bit slash 16-bit image. Okay, so the issue was with me changing the unsigned range and assigning a complete bit depth versus keeping it automatic. So that was the issue, and we are back on track now. All right. All right, how's everybody doing? All right, cool. We'll move on to the next one. So once you have any of this image open in front of you, what you can do is a bunch of other options, which might be very handy when you are doing a bunch of stuff with your data. So you can split these images into individual images. Right? So I'm going to duplicate my image so that I don't lose my image, right? And again, with duplicating, what you will see is when you have multiple channels or a hyperstack, it will tell you how many channels you want to duplicate, right? So if I want just channel number 2 from this, I can say, okay, it will give me my actin channel. If I want all 3 channels, I can say this is what I want, and it will duplicate everything, right? So duplicate tool is really handy in that way in terms of splitting channels and whatnot. So let's say this is the channel I have, this is the image I have, and I want to split my channels. Okay, so let me pull up my toolbar, image, color, and split channels. So I get individual images this way also. Once you have images like this, you can put them together. So image, color, merge channels, all right? And this is supposed to work in a certain way, but it's not working in a certain way. And I'm keeping my fingers crossed that it does behave the way it's supposed to behave. So what's supposed to happen is, if I say I want my first channel to be, let's say, gray, right? I want my first channel over here. I don't want any of this guys to be what they are. I want my second channel to be gray and my third channel to be yellow. And I want to keep my source images and create them. It's supposed to give me 3 channels with the colors I asked it to do, but it doesn't do it. I don't know why, okay? So just kind of throwing this out to you. It is what it is, but you can change the lookup tables whenever you want to, so that's not a problem. So if I go back to this image, right, and I say that I want the first one to be blue now, the second one to be
If you click ignore source LUTs, will it get rid of the LUTs that we already set and put it as the colors you want?
Yes, you are right. That might help. Thank you. I totally ignored that. I think you are right. That's exactly how it's supposed to work. Let's say C1. Yeah, thank you. I totally got blindsided by that. Okay, so that's that. And the second point is, if you want to copy this, let's say into PowerPoint. So you cannot just go edit and copy something and then paste on, let's say if I want to paste something over here, it doesn't let me paste, right? So it pastes whatever I had last time. So you need to do edit, only if I can get this, edit, copy to system, and then if I do paste, I get the image. So that's one thing about Fiji, which is you have to do edit, copy to system, and then paste something. You cannot just do Control-C and paste, okay? So one of the ways you can do something is create a shortcut. So if I go to Fiji, window, actually plugins, shortcuts, you can add a shortcut. So I've assigned a shortcut of Control-0 to copy to as a copy to system, because I know I do have to copy quite a bit. So I don't want to go to image or edit, copy to system, and then paste. So if I just hit Control 0, and then, or let's say do something new, Control 0, Control 0, and then just paste it over here. I get my image, right? So shortcuts are really helpful if you end up using something more frequently. It comes very handy. All right, so this should take a couple of, and actually the last thing is, if you have an image like this, if you want all the channels together, something which I talked to you earlier was to convert this to an RGB color image. So now you get one image with all three colors as merged together and not a composite image. So in this image, you cannot change the channels the way we are changing over here and do any transformations, okay? So that's pretty much it for this. Take like a few minutes and we will reconvene after that. How is everybody doing over here? I think this was straightforward. And thanks for the help. I got into my tunnel vision and never saw that I did not check, ignore the current lookup table. So thank you for that. All right, so moving on, this is more like a comprehensive exercise on everything that you have looked so far. I acquired data which was nice as well as not so nice, right? So in your image comparison folder, you have got 4 different images, and you don't need to open all 4 of them. you can open, let's say, undersaturated and just right, or you can open super saturated and undersaturated. But the goal is between two of the images, do the following operations, right? Use a line tool or the rectangle tool. Make sure that whatever tool you are using, you are saving the same region in the ROI manager. Draw a plot profile, generate plots for different images. And the idea is to know what kind of signal to noise that you are getting, yeah, right? So if you are not acquiring data in a nicer way, the signal to noise ratio is pretty terrible. If you're acquiring data in way nicer way, everything is very saturated. And if you are acquiring data in just the right way, the signal to noise ratio is just perfect. And that's what you want to do. So follow the instructions over here. I'll also be opening some of the images, and it would be great if some of you can take screenshots of the plot profile from 2 different images with the same ROI and share on Slack, so we know that everything is going perfect. We are able to make some of these important points across to you. Okay, so while you are working on this, I'm also working on this, and we'll all be doing it together. And you don't need to use all 3 channels. You can just use one of the channel from the 3 images, right? So you can open the 3 images, but you can just use one of the channel, right? So duplicate and use just 3rd channel or 2nd or whatever you want. I'm just gonna use my 3rd channel. You can use any channel you want. And if somebody wants to point out an obvious error that I made, I think I did not give you really perfect images. What I did was 2 of the images are zoom and 2 of the images are of the full field of view. So even if you end up drawing a line on, let's say, saturated versus undersaturated, you cannot compare them because they are of different magnifications, right? So I guess the point I'm trying to make is you can only do comparisons between saturated and supersaturated, and comparison between undersaturated and just right. Okay, so you'll only be able to compare between either or. So I'm going to take a snapshot and post my data. So would anybody like to discuss what they saw and what they feel about this comparisons, how this graph can help you tease apart some of the changes, help you know what's going on in the image, because this can be very informative in general when you are doing imaging-based experiments. How do you all feel about this exercise?
It is at least what I did was to compare undersaturated and just right. And
Okay.
what changes is the scale in the y-axis.
Right.
So how do you know what's just right in that sense? Because the plots are very similar. It's not like when you compare the super saturated that the peak seems to be above the y-axis, right?
Right, I agree with you. When we compare, let's say, plot of, and if I increase this plot of just right and undersaturated, I can probably help you highlight some of the changes. So for example, your lowest pixel, so signal to noise, right? What is the background? The lowest that you are getting is about 183. What is it that you are getting over here? It's about the same, in about 180 or something. But when you look at the highs over here, right, the highs are pretty high. So your signal, if you talk in terms of signal to noise ratio, you get a better signal to noise ratio. Now, is the undersaturated image a terrible image? I would say no, right? If you were to change the display and show it, I can make it look the way the just right image looks like. It's totally fine. So your point, which is one better than the other? Both are in a way acceptable image, except that your just right image has a tad bit better signal to noise ratio compared to your undersaturated image.
Perfect.
Okay.
All right. Thanks.
Yeah, perfect observation.
Mhm.
Now, in contrast, if you look at the saturated image, right, this is where things become much more obvious that for just a saturated image, we are kind of reaching 4095s over here. It's a 12-bit image, right? So a 12-bit image, your bit depth is from 0 to 4095. 4095 is saturated. And because we are looking at the same regions, we want to, if we compare this guys versus this guys, these guys are off the roof, right? They're touching 4095s. If we compare this peaks over here, right, and this peaks over here, these peaks are just right. The shape of the peaks, it's very similar. However, when we look at how far these peaks go, these peaks over here, they go off the roof, whereas these guys are just right. Okay, so though I said it's saturated, there are very few pixels which are saturated, and these are like super saturated. So this is more pronounced difference compared to the difference of just right versus the undersaturated. Okay. And feel free to reach out to me if you have more questions on this, even later on. But I want to get moving because we're almost on the top of the hour right now, and want to make sure that I don't hold you up with your dinner or whatnot. Okay. So I'm gonna close this windows. And move on with 3D, which all of you love, all of you image. So with 3D, we're gonna open the next image, which is 3D Filopodia. And so just gonna drop it onto Fiji. We have this nice looking image. And what I'm gonna do is create a 3D projection, simple way, image, stacks, 3D project. And I'm going to click on interpolate, which you should also do, because if you have big intervals between two Z stacks, the interpolate will try to smooth your image out. That's not the case with this image. I do not have big intervals or big gaps, so I'm fine with that, but typically you should interpolate. And once you get a nice reconstruction, you can rotate this, okay? Looks perfectly nice. And you can save this as a movie, right? So I can go and say File, Save As, AVI. It will ask me how many frame rates and so on. I'll just say I want 5 frames. That's also if 7 is okay with me. And I'll save it over here, projections of Filopodia. Can go to my folder, and I got a movie like that, right? So it's straightforward, easy to show your 3D data. You can also do a max projection. Real quick, what max projection means: image, stacks, Z project, and max intensity. What max intensity projection means is it's throughout the entire depth that you have in Z, it's going to identify the brightest pixel and use that brightest pixel to project in front of your image in the projected image. Okay, so I can select the start and stop slice and say okay, and boom, I get this image which has the maximum pixel intensity throughout the depth of my image. Okay, so a lot of people like to use this too. Now, typically I would, since we are running out of time, you can install a Z-Stack depth color code plugin from this instructions. And if you were to use that, it will look something like that. It will be under plugins. Color. And it's in such a non-obvious place that I always forget where it's going to go and stay. Let me just type in the name if it pops up. Typically it does not. Z-Stack. So it's not popping up, that's okay. It's one of the places in plugins, under plugins. How about this? While you guys keep on playing with these two things, I'll look at that. But before I play with that, I also want to show you one of the plugins, which is very helpful. It's a very low-tech version of getting a nice 3D stack or a 3D view. So you can go to 3D viewer. And also I want to display this as volume. So it will open up a window and I can play with this nice volume over here. And if your computer is kind of nice with good amount of RAM, this will work very fine. But if you do not have enough RAM, this will be very laggy. Okay, so just want to give you a heads up on that. I can also do, let's say, display this as surface mesh. So I'll get something that looks like a surface mesh over here. Okay, so there are different options that you can do, and it's lagging because I have two different things open. 3D viewer, I can also look at this as ortho slice. So I can slice through things, right? So I can zoom in and look at different slices. I can cut through them. Right, so I'm going through individual planes. If you do X, Y, and Z, you can move through different planes of the image, right? So I'm right now, this is my bottom, this is my top. Let's not make it very confusing. So if I want to go through Z, I'm moving through Z slices. If I want to slice through my X, I can move through my Y right now and my X right now and my Z, right? So that's how you can move between slices. So that's that. I also want to show you one last thing, which is cells with 3D particles. Okay, so if you open that file, the orthogonal viewer. All right, so what does orthogonal views mean? So let me do Shift Control H. It will turn on the orthogonal view. Right now, what you are looking at here is a two-dimensional view. However, if you want to see exactly how your particle or a pixel or a point spread function of that pixel is in Z dimension, you can go to the ortho view. And this is exactly if I'm going to look from top to bottom of this particular bead, that's how it's going to look like, right? It's gonna look from top to bottom and it's gonna show this to me. And this, if I scroll through my Z, it will remain constant, right? So if we, or if you kind of focus on this one right here and this plane right here, as I scroll through my Z, you will see that in 2D, the particle moves in and out, but in Z plane, this particular line goes through top and bottom, right? So we are looking at how this particular region looks from top down. Okay, so that's what essentially the orthogonal view is doing for you. Okay, so that's kind of straightforward. You can play with that for 5 minutes. And I apologize, we are running late, but you can play with that for 5 minutes. Let me know if you have any questions. And then we can wrap it up with one last thing, which is how to add scale bars. All right, so I'm sorry to interrupt to what you are doing, but real quick, the plugin I was talking about is under stacks, Z-stack depth color code. And I'm gonna say I want a spectrum lookup table. It will convert all those images into this kind of a spectrum lookup table. So each color is assigned to a certain depth. And then if I do image color, or sorry, stacks 3D project, it will give me a nice colored volume projection of this. Okay, so this is what I get. It's nice colored projection. All right. So you can download this plugin, install based on the instructions that is in the link, and you should be able to replicate. And if you have any issues or questions with that, do let me know.
So these different colors in Z stack, does they represent depth or does they represent different intensities?
It represents the depth.
Okay.
And there was a cheat sheet that went along with that. So it also gave you, sorry, if I can pull this, okay. So also give you how this depth looks like from top to bottom, the whole rainbow lookup table. So yeah.
Okay, thank you.
Sure. All right, how is everybody doing? Need some more time? I'm gonna wait for like 30 odd seconds and then we'll quickly demonstrate one thing to you so that this kind of gets written in your head as to what kind of issues might arise if you don't do it in a particular way.
We're getting thumbs up from the participants. I think they might be ready.
Oh, okay. Thanks, John. All right. So I'm going to skip ahead to exercise 4.2 and then come back to exercise 4.1, which is adding scale bar. Since I already have this images open over here. Okay. So one of the thing I like, one of the features I like is combining the images. And what combining images means is you want to display two images side by side. Okay. Typically, you would cut, copy, paste, and things like that. But if you just want to quickly combine two images together, one thing is make sure that your aspect ratio or dimensions of your image are matching, even if it's different by 1 pixel, right? This is 544 by 512. And if the other one is 544 by 513, you won't be able to combine an image, and you need to have the same bit depth. This is an RGB image. This is an 8-bit image. So what I'll do is I'll convert an 8-bit image to an RGB image, go to image type, RGB color. Okay, so now if I want to combine my images, I'll go ahead and type combine. And so it says combine image stacks tool combine. This is the one I want to use. And it asks me what I want to combine. So I want to combine 3D. Well, I want to combine projection, not 3D Filopodia. So projections of 3D Filopodia with projections of depth coded color 3D, and say okay. So now I got an image which is like this, right? So sometimes people might have difficulty looking at just the colored ones, but if you have the grayscale image next to the colored one, it becomes very easy, and it looks nice on your presentation if you want to, right? So this is what you can do with combined tools, and this can also be used with individual single images. Okay, so you can play with this later on at your free will. All right, so I'm gonna go back to one of the images which you have, which is crop composite. So I'm gonna bring it here, and what I'll be doing is showing you how to add scale, right? So I forgot to add that you should be opening crop composite. Now in this image, what you are seeing is that you already have a defined scale to it, right? So if I go and type in scale, there are multiple options that come for scale, but the two options that you need to focus on is the scale bar and image set scale, which is the one on the last, right? So first thing, if you do not have any scale set, you can click on Analyze Set Scale. I'm going to run that, and it will ask me to define the scale, which you will ideally do in pixels per micron. If you don't have this information, you can ask us if you're using our scopes, or somebody else from your lab if you're using your lab scope. Okay, so I'm going to enter 2.64 pixels per micron. So this is based on per micron, and type in unit of length either as microns, or you can type in UM. That also sets for micron. Now, if you have multiple images that has the same scale, then you can click on global. But if different images have got different scales, then I would not recommend you to click on global. Okay, I'm going to say okay, and then again go to scale and scale bar. So I want to put on a scale bar now. Say run scale bar, and boom, you got the scale bar right away. Okay, so you can say I want scale bar which is 10 micrometer in length. You can change the height over here, let's say 8, and it increases the way you change it. You can increase the font size, say 50, whatever you want to. Let's make it something more okay. You can make it anywhere you want to, upper left or wherever you want to. And yeah, that's pretty much straightforward. The other thing also is, let's say if I go away and if I use this line and make my line right here and go back to my scale bar, run, it will give me scale bar right where my line selection was, right? So if you don't want to do upper left, right, whatnot, you can always make a selection anywhere you want, and you can get a scale bar. All right, so I'm gonna go lower right over here. And the other thing you can do is save this, right? So if you want to save this image with the scale bar, you can do something called flatten, or you can simply convert this to RGB image the way you saw. So image type RGB color, it opens an image where the scale bar is embedded, and you can copy and paste this image wherever you want to. All right. So that's pretty much it that I want to discuss. Play with the scale bar real quick for 5 minutes and let me know if you have any questions. Okay. And then we can wrap the session up. So I just want to kind of quickly go over for what we will be having for the next session. And I apologize, this went way over. I should make it clear that next session might go a bit over because that's the most intense session when it comes to image segmentation and intensity measurements. We will be going over something like this, where you will be thresholding image, masking image, using a bunch of options such as watershed function. You will doing a bunch of image math and some more. So in advance, I just want to let you know that we might go over 6 o'clock next time because it's going to be quite a bit intense. Okay, so sorry about this. I really underestimated myself in terms of planning things today. And thanks for sticking. Yeah, absolutely. If you have any questions, do follow up with us on Slack, send us a message, and we'll see you all next week. Thanks for the feedback. This is really appreciative. I like your feedback. Thank you all. I'm glad it was helpful for you, Jessica. Thanks. So we're gonna wrap the session up. Thanks for hanging in, Bo. We're gonna stop sharing and end the session. All right, Stan.